All right, so this video is reviewing the paired or dependent samples t-test. And we're talking about this in green. You can see we're talking about one independent variable with two levels. So it's still dichotomous, but the difference is that we have dependent or matched groups. We're still going to have one dependent variable that's interval or ratio, and this is going to be in SPSS that I'll demonstrate this. So as a quick reminder, when we're talking about the dependent or paired samples t-test, we have one independent variable that is categorical and dichotomous, so it has two levels. But the difference here from the independent samples t-test is that they are dependent or related or matched. So for example, if you had someone or you had your participants complete one condition in your experiment, and then they also complete the next condition. There's two conditions, and you're going to compare them against themselves, really. So you're using people as their own controls for your experiment. It could also be matched pairs in different ways. So we've talked about husbands and wives and their satisfaction with marriage, for example. So we're no longer talking about unrelated groups. We're talking about related groups or that are dependent in some way on each other. So I'm going to go ahead and go into SPSS and give you an example. So in this example, we have two variables here. So I don't have any of the descriptive information. So to keep it simple, we have a yoga data set. And what we're looking at is each person in this data set. So one row is a person. They completed yoga with light, and then they also completed yoga with no light. And after each of these conditions, they completed an enjoyment survey and they noted their enjoyment. So we could look at this descriptively initially, but we're just going to go ahead and jump right into our analysis. So we're going to do a dependent samples t-test because this person, their scores, they're dependent on the same person. It's the same person. So they're paired, right? They're not independent because it's the same person's scores, just at different conditions. So this is one example of a dependent samples t-test. So I'm going to go to analyze. We're still comparing means. That's what a t-test is. It's comparing means. And we're going to do a paired samples t-test. So you will hear it listed as paired samples, as dependent samples. There's a lot of different ways people talk about this type of test. So here you can see that we have our light enjoyment of yoga with light and our enjoyment of yoga with no light. So we're just going to move those over, and we're going to say variable 1, if my computer wants to behave, and variable 2 is going to be the other measurement. So variable 1 is this first measurement for the same person, and then the second measure for the same person for all of these people in our data set. So we have 15 people in our data set. I do want to calculate the effect sizes. I do want the standard deviation. And I think that's all I'm going to do for now. So I'm going to say okay. Here we have our paired samples t-test. So again, we could go into our information here and we can copy this. We can copy our syntax and we can copy and paste it. So I could go ahead and paste this right here, and I could complete this again. Notice that there's a lot of information in here. You don't necessarily need all of it. So it kind of varies depending on what you're looking for. But again, I recommend kind of playing around with the syntax and seeing what happens when you change things so that you can get used to how it works. So here, let's talk about our results. So we have our paired sample statistics. We have a mean, a sample size, and a standard deviation and standard error for the mean, for the enjoyment of yoga in our light and no light condition. Forgot what we were talking about for a moment. So now we have the paired samples correlation. Again, we talked about this. We don't really use this paired samples correlation. What we're looking for is this paired samples difference, paired samples test. So these are descriptive statistics. That helps us describe our sample. But we want to know, is there a relationship between these two measurements, or is there a difference between them? And is that a real difference, or did we just get it by chance with our population or with our sample? So here you can see that this is all paired differences. So there's a difference of negative 2.2. So that comes from condition 1, 8.27 minus condition 2 at 10.47 is negative 10.2. We have our standard deviation of 10. And then we have our standard error of the mean at 2.61. We have our confidence interval, which we have lower and upper levels. And again, we're going to get into this more later, but if your confidence interval of the difference includes 0, it's not going to be significant. So we're still doing a t-test, and this is where we're really going to focus, is these last 3 parts here. So T, degrees of freedom, and we have the significance for two-tailed. I'm in a slightly older version of SPSS, so it doesn't automatically give me the one-tailed and two-tailed. The rest of you are working in a newer system or on a Porto, so it will be there. But just to interpret this, we're saying that our T value is negative 0.84. Our degrees of freedom is 14, because that is our total number of people minus the number of groups we have, and we just have one group, so that's going to be 14. And our significance is 0.41. So this is not less than 0.05, which is our standard alpha level. So this is not significant. So we are going to fail to reject our null hypothesis. And our null hypothesis is that there's no difference between these measurements, between these 2 different measurements. And so we don't have evidence of a meaningful difference. So if we were to talk about this just conceptually, we would say that there's no difference in enjoyment of yoga between the light condition and the no light condition. We also have a point estimate here. So Cohen's d is very small. So it's not only not statistically significant, it's not practically significant. It's very small Cohen's d, so we can say it's a very small effect size. So again, with your syntax, you can go in and try things out. So for example, we're going to delete those zeros that are in there. And if you run it again, you're going to notice it doesn't change anything. It just happens to run that as the default, and it's slightly different than the other tests we've run. So some of this information isn't necessary. So you can take things out, you can modify things, but the key here is that you're saying it's a t-test, and then we're saying it's pairs because it's a paired samples t-test. And we're saying that our pairs are equal to enjoyment light with our second pair, or second part of the pair, which is the enjoyment no light. And then we put pairs again in parentheses. So these, again, you're probably starting to see a pattern in this syntax. But I do recommend going in and kind of messing around with the syntax and seeing what happens with it. So that is the end of this video. And we will resume with some one-way ANOVA.